Question number 3 is talking about the volume of lemonade in a bottle. So again, we'll start by saying X is equal to the volume of lemonade. And X is normally distributed. It tells us it's normally distributed with a mean of 1,000 and a standard deviation of 22.5. And in this little box I write 22.5 squared because that's the variance there. Issue here that this is all in litres and we're measuring now in centimetres cubed, and so we need to be thinking here about 1050, here about 1010, and here about 980. And what have we got here? Here about 950 as well. Part A then, find out the probability that you've got more, that X is more than 1050. Convert it. Z is more than 1050, take away the mean and divide it by the standard deviation. That says we're looking at Z to be bigger than 2.22. Let's draw my little picture. Here's my normal distribution. 2.22 is very high up here, and it's a more than, so I'm going to have to look up 2.22. That gives me the bit down there, and then do 1 minus it. So I'm getting 0.013. 1313 on the calculator there. Part B, it's the between question again, one that worries a few people. The method of between is you say, what's the chance of it being lower than the top number? Take away the chance of it being lower than the bottom number. That will give us what's in between. This one here, convert that. That goes to our Z value of 0.44. And this one here is quite small, so we want a Z value of minus 0.89 there. Look up those two things individually, do one, take away the other. You do get 0.4833 on the tables, or on the calculator 0.484. You get different things because the calculator's got more accuracy to it and the tables less so. Part C, a couple of ways you can do Part C. You can either take the 98% and work backwards to try and see what value it would be, or I'm just going to do the same thing again. The probability that X is lower than 950, let's just go for that. The probability that X is lower than 950 is the probability that Z is lower than 950, take away the mean, divided by the standard deviation. So the Z is lower than, is that minus 2.22? And the chance of Z being lower than 0.22 is just 0.1321, I think. I'm just working that in my head as we go. So we've got a really tiny percent. Let's how much is bigger than that? Well, how much is bigger than that is the opposite. The probability that Z is bigger than minus 2.22 is actually 0.986. So we've got 98.6 bigger than it. So what are they saying? 98% is bigger than it. We're saying 98.6. So therefore it's true. We agree that we say 98.6 is bigger than. That's more than even they were saying. So we agree with that.